We are picking up in lesson 2.6. Remember yesterday we learned the quadratic formula, yes? So we did a lot with quadratic formula yesterday. Be familiar with it. It'll be provided on your formula sheet, but be familiar with it. We looked at solving, all kind of the different ways to reduce. On the back side of the notes, we're going to use just a portion of the quadratic formula. And this portion that we're using is the portion under the radical, and it's called the discriminant. Okay, we're going to use a discriminant. The discriminant being b squared minus 4ac. I knew it was written there somewhere. I just forgot where. Okay, so that discriminant, it's just the part under the radical, can help you know how many solutions each problem has and the type of solutions. So yesterday I was kind of going over that vocab and helping you figure that out a little bit. So this is a quicker way if you just need to know how many solutions. Okay, so in this first example, if b squared minus 4ac is greater than 0. What do I mean greater than 0? I mean if it is positive. So if b squared minus 4ac is positive, there are two real solutions. Okay? If b squared minus 4ac equals 0. Okay, wait, let me back up. Two real solutions being, remember, where are solutions? Places where the graph crosses the x-axis, yes? If b squared minus 4ac equals 0, there is one real solution, and that's right here, because the graph only touches the x-axis in one place. And then, if b squared minus 4ac is less than 0, what do I mean when I say less than 0? Negative. If b squared minus 4ac is negative, notice how it's stated here. It says two non-real solutions. Two non-real solutions meaning two imaginary solutions. Okay? So when we talk about two non-real solutions, this is also the same idea as, and I don't think it really asks it in your homework, but it means there are no real solutions in that scenario. And you'll notice here, my graph does not touch the x-axis. So there's no real solutions, there's just a couple of imaginary solutions. Okay? Now, what we're going to use this for is there's sometimes scenarios and word problems and stuff where we don't need to know what the solution is. We just need to know if there is a solution, how many solutions. So, in these practice problems right here, we're going to find the discriminant. So we're going to find what b squared minus 4ac is. And then we're going to use it to determine the number and type of solutions. So, is there two solutions, one solution, real, non-real solutions? Okay? Nice part is, it's quicker and easier than quadratic formula. So, find the discriminant. Shall I start like yesterday? If we're going to find the discriminant, we need to know our ABCs. So b squared minus 4ac is the discriminant. What is a on this problem? 16. What's b?
8.
B is 8. And what's c? C is 1. Okay, that's review from yesterday. A is in front of x squared, b is in front of x, c is at constant. If we're filling in b squared minus 4ac, fill in your numbers. B squared, so 8 squared minus 4 times A, which is 16, times C, which is 1. Okay. You might want a calculator by your side. Just saying. 8 squared is what?
64.
64. 4 times 16 times 1?
64.
64. And 64 minus 64.
0.
Big math there, right? 0. So we just learned that our discriminant equals 0. With that in mind, it asks us the number and type of solutions. If my discriminant equals 0, what's that mean?
One real solution.
There's one real solution, yes? Okay. And if you were here yesterday, it relates back to, you remember on the front side, we had one that had one real solution, didn't we? It was this example D here. When b squared minus 4ac under the radical became 0, we only had one solution. That's exactly what the discriminant is telling us. So this is one real solution. Okay. It would be a repeated solution because it would occur twice in terms of factors. But I believe all you need to know is the one real solution. Okay, questions there? Okay, what about B?
There's no equal 0.
Okay, there's no equal 0. Does that matter? Yeah, because in order to give me the proper ABCs, the equation has to equal 0. So we should probably maneuver this a little bit, shouldn't we? How am I going to make this equal 0?
Subtract the 5x and add the 6.
Okay. One option would be to subtract 5x and add 6. And so if that's the case, I'm going to have 2x squared minus 5x plus 6 equals 0. Could you have subtracted 2x squared instead? You could. Okay, all your signs would just be the opposite, but it would still work. Okay, well, we need to find the discriminant. B squared minus 4ac. I'm going to write down my ABCs. A is 2, it's in front of x squared. B is negative 5, it's in front of x. And C is 6. Okay, do the math. B squared, I'm putting in negative 5 squared minus 4 times A, which is 2, times C, which is 6. Okay, guys, be careful. What is negative 5 squared?
25.
Positive 25, yes? This for B squared will always be positive. So 25 minus 4 times 2 times 6. Okay, so 25 minus 48. What kind of answer is this going to be?
Negative.
25 minus 48 is a negative. Technically, do we have to know negative what?
No.
Technically, no. I just need to know that it's going to be negative. Now, 25 minus 48 is going to be negative what?
Like 23.
Yeah, negative 23. All I care about here is that it is a negative. Okay, that's what I care about. It is a negative. What's that mean about my solutions if my discriminant comes out negative?
No real solution.
There's no real solutions. How many non-real solutions are there?
2.
2. And I think that's what they're going to want, is they're going to want to know that there's 2 non-real solutions. Okay, so 2 non-real solutions. I think I also mentioned yesterday that they are complex. Do you remember what it means to be a complex number? Complex numbers are numbers that are in what form? I don't know if I wrote it down in your class or not, but A plus, yep, A plus BI. Okay, so again, the piece I care about here is the 2 non-real solutions. Now, did we have that happen yesterday? We did. We had, where was it? It was up on B?
Yeah.
Yeah. What happened? Under our radical, we got a negative. That gave us two non-real solutions because there was an I involved. Okay? Okay, are we seeing how we do this? The key here is to know what the discriminant means. Is it positive? Is it negative? From there. Okay? Okay, let's try a couple more real quick just to practice what kind of solutions they're going to be. C. X squared plus 7x equals negative 11. What are you doing?
Adding 11.
Okay, I've got to get this in a form so it equals 0. So I'm going to add 11 over. Now I have the equation x squared plus 7x plus 11 equals 0. Okay, make it equal 0. You can go ahead and jump right into your discriminant if you want. As the teacher, I've been writing down my A's. Just make sure everyone's on the right track. What is A?
1.
1 because it's in front of x squared. What's B? 7 because it's in front of x. And C? 11 because it's the constant. Okay. B squared minus 4AC. So 7 squared minus 4 times 1 times 11. Are you doing the math or are you making me do the math?
It's 5. Or
I agree.
It's 49 and negative 3.
I was with you. It's 5. I'm there. 7 squared is 49. 4 times 1 times 11, 44. And 49 minus 44 is 5. Most importantly, it's what kind of 5?
Positive.
It's positive 5, correct? That's what I really care about, is that it is a positive. What's that mean about solutions? If you get a positive number under the square root.
That it's 2 real solutions.
2 real solutions, right? There's going to be 2.
Ashley, stop scratching. Nice.
There's going to be 2 because when I do plus or minus the square root, there's going to be 2 different numbers that answers that you're going to get. They're going to be real because I can take the square root of 5 and get a decimal, but it's a square root. So 2 real solutions. Now, let me write this down. And then yesterday, do you remember us talking about rational versus irrational?
Yeah.
Think about if this would be rational or irrational solutions.
Rational.
And here's the question. What number would be under the square root? What number would be under the square root? In other words, what's normally under the square root? It's the b squared minus 4ac, yes? So if this would be under the square root, and I'm not doing the square root, but what's that mean? This would be the square root of 5. And what do you know about the square root of 5?
Yes.
It's a long, messy decimal. So this is what type of number? Irrational. Okay? So just realize, and I have it in my notes, so I don't remember if it comes up in homework or not. But if it's asking about rational or irrational, think, can I take the square root of what's in the square root? Is it a perfect square where it's a nice neat number, or is it a big, long, messy decimal? Big, long, messy decimals, irrational. Okay? Okay, one more. 6x squared minus 15 minus x. Before we can identify our ABCs, we're going to
Add the x.
add the x. Now, what's the catch here when we add the x?
It's got to go after the 6x squared.
Yeah. I guess you don't have to put it in order, but I'm always going to recommend you put it in order. X squared first, then the x term, which is a plus x, and then the minus 15. What is A? 6. It's in front of x squared. What is B?
1.
1. It's the invisible number in front of x. And what is C? Negative 15. It's the constant. Okay. B squared minus 4AC. Plug them in. 1 squared minus 4 times A, which is 6, times C, which is negative 15. I got the 1 squared part for you. 1 squared is 1. You get the next part.
Like negative 360.
Okay. I had to stop and think, but my brain did 4 times 15 is 60. 4 15s is 60. And then 6 times 60 is 360. Now, did you say negative or positive?
Negative. Oh, it's positive. Yeah.
I do have to disagree with that now that I was hooked on the 360 trying to get that number.
Yeah, I was doing that too.
Okay. Negative 4 times negative 15 is going to make it a plus. What do we know about 1 plus 360?
361.
It's 361, and most importantly, that is positive. Okay? It's positive again. What's that mean? There are 2 real solutions. Now, how am I going to determine, if I had to, whether these are rational or irrational solutions?
Square root.
Yeah. What kind of square root is 361? Okay, so in other words, think square root here. What kind of square root is 361? I say it comes out nicely, doesn't it? And do you know the square root of 361? Probably not most of us. Okay? However, your calculator does, right? So plug it into the calculator. Square root of 361 is 19. That means these are what types of solutions?
Rational.
They are rational because you can take that square root. Are you following my thinking there? The difference between C and D. The number I got, 5, I couldn't take the square root. This number I got, 361, I can take this. It is a perfect square. We can always take the square root. I need to say specifically perfect square. Okay? Okay, one more.
Bro, why does Dion keep throwing the ball? Why can't Dion take a break?
Well, it's the same. It's a follow-up from the problem yesterday. It's the same person, Dion. Jocelyn's obviously bugged by that. It's the same equation. Okay, so Dion's still throwing a ball into the air just like yesterday. The height h of the ball in meters at times t seconds is modeled by this function. So all that is the same. Yesterday, it was when will the ball hit the ground? And we know the ground has a height of 0. Today it is, will the ball reach a height of 5 meters?
Then
That's what it is.
Now, I'm not asking when will the ball reach a height, it's will the ball reach a height. So basically that's a yes or no question. That doesn't mean you just guess. Okay?
50-50 shot.
It is a 50-50 shot. I agree with that math, but we're not going to just guess. Will the ball reach a height of 5 meters? Where does that mean I put 5?
HT.
Yeah. This is going to be, we're going to make h of t equal 5. So we're going to take this equation here and make it equal to 5. So I'm going to write out my equation. Negative 5t squared plus t plus 4 equals 5. Will the ball reach this height? I just need to know, yes, this problem has an answer, a real answer, or no, this problem doesn't have a real answer. Do I have to do the whole quadratic formula? No, you could, but what could we do? how do we find out how many solutions and what types of solutions there are? You could use your discriminant. You can use b squared minus 4ac and determine what types of solutions there are. Now, before we can use b squared minus 4ac, what do you have to do? Before we get our ABCs, this has to equal 0. So to make it equal 0, I'm going to subtract the 5 over. My equation, when I rewrite it, is negative 5t squared plus t, 4 minus 5 is minus 1, equals 0. With this in mind, A is negative 5. B is invisible 1. C is negative 1. Plug them in. B squared, 1 squared, minus 4ac. 4 times negative 5 times negative 1. One squared is 1. Negative 4 times negative 5 is positive 20 times the other negative 1 does make this negative 20. What do we know about 1 minus 20? It's negative 19. What do I care about this?
No, the answer is no.
Okay. Negative 19 is negative. A negative discriminant means there are two non-real solutions. So it means two non-real solutions, but two non-real solutions means no real solutions. And folks, if we're talking about will the ball reach a height of 5 meters, we need to talk real solutions here. So since there are no real solutions, that means no, the ball will not reach a height of 5 meters.
I knew it.
No, the ball will not reach a height of 5 meters. Okay. Something strange just happened.
What?
We finished the lesson.
For real?
Yeah. You've got just under 20 minutes of work time.
What?
Oh, man, I thought
Crazy thought.
I thought that was the last lesson. I was about to cry.
We still have 2-7 that we'll do tomorrow and Friday, but you have some work time on 2-6. Okay? So use it. If you have questions, I'm available, and Miss Pavin are available. Ask if you need help.